Let us look into the problem. One of the eigenvalues of a 3 by 3 matrix M is given as 3 and its determinant is 24 and also given that trace of the matrix is 9. Then we have to find the smallest eigenvalue of the matrix M inverse. Now, let the matrix M be A00, 0B0 and 00C. Now, they have given mod A, mod M is equals to 24, which is nothing but ABC, that is 24. And also trace of this matrix M is given as 9. Trace is nothing but the sum of the principal diagonal elements, which is A plus B plus C is 9. Now, one of the eigenvalue is given as 3. Let it be some A. A is equals to 3. If A is 3, then from equations 1 and 2 we have BC is equals to 8. If you substitute A as 3, then we can go for cancellation. Now, B plus C will be equals to 6. Now, if we solve these equations, let us say 3 and 4, the values of B and C will be 4 and 2. Now, the matrix M will become 3 0 0 0 4 0 0 0 2. Now, let us find M inverse. In order to find M inverse, we already know mod A is equals to mod M is equals to 24, which is nothing but 1 by 24 into find the cofactors of this, which is nothing but 8 0 0. Next, cofactors of these two values will be always zeros. Next, cofactors of, let us say, these values, it will be, if I take this value, it is 6 0 0 0, and then for the last one it will be 12. Now this matrix M inverse will be 1 by 3 0 0. Next, 0 1 by 4 0 0 0 1 by 2. So the eigenvalues are 1 by 3, 1 by 4 and 1 by 2, and the least among them is 1 by 4, which is 0.25. That is option B.
In this question, we have to find voltage across this high impedance voltmeter. If you look at this bridge is nothing but a wheatstone bridge. Okay. And this product of opposite impedances are not equal. So bridge is not balanced one. Okay. If this bridge is not balanced one, definitely voltmeter is not equal to 0. Option A is wrong. Okay. Now we have to find the voltage across this voltmeter, just like a Thevenin circuit. Okay. Now we have to find voltage across this voltmeter. Treat it as load terminals. Treat it as load terminals and make it open. Okay. Now this is 10 ohms, 20 ohms, 10 ohms and 20 ohms. Mark these load terminals as A and B. Okay. Supply voltage is 10 volts. Okay, current flowing, let us take it as I. Okay, now what is current I here? Current I is equal to, okay, 10 by, this is 10 by 30 parallel to 30 ohms. Okay, 30 parallel to 30 ohms, so this is 10 by 15, which is equal to 2 by 3 amperes. Okay, 2 by 3 amperes. Okay, now if you see, mark the drop terminals of the current. Here current drop terminals are plus and minus. So this is plus and minus. Similarly, you have this is across 10 ohms is plus and minus, and this across 20 ohms is plus and minus. Okay. Now VAB is equal to VTH. Okay, let us take A is at higher potential, B is at lower potential. Now write KVL in this loop. Okay, if you write KVL in this loop, V 10 ohms minus V 20 ohms is equal to VTH. Now what is VTH here? V 10 ohms. Current flowing through this 10 ohms is 1 by, okay, since this is 2 by 3 amperes, okay, this is 2 by 3 amperes, current flowing in this one is 1 by 3 and in this one is 1 by 3 amperes. Okay, now what is voltage across this 10 ohms? Voltage across this 10 ohms is 10 into 1 by 3 minus voltage across 20 ohms is 20 into 1 by 3. So this is minus 10 by 3 minus 3.33 volts. Option C is correct. In this question, he has given a 4-bit serial in parallel shift register. Okay, this shift register used the feedback as shown in figure, and he also given a shifting sequence. Okay, you have QA shifted to QB, is shifted to QC, shifted to QD. Okay, and initial value of these QA, QB, QC, QD is 1. Okay, this is what initial condition we have. Okay, now what we have to find here, we have to find when the output is going to be repeated. That means when again this initial condition is going to be appeared in this shifting sequence. Okay, initial conditions are 0, 0, 0, 0. Now when you have given a clock pulse here, now what should be the output of these 4 registers? This QA is shifted to QB. Now this B is replaced with 0. Okay, similarly QB is shifted to QC and QC is shifted to QD. Okay, now what is the input of QA here? QA input is equal to, okay, QA is equal to QB XNOR QD. Okay, what he has given here is an XNOR gate. Now what is the truth table of XNOR? Let us take, this is QB, QD and QA. Okay, now what is this one? XNOR gate. Okay, write on the truth table for XNOR gate 0, 0, 0, 1, 1, 0, 1, 1. Okay, now what is the output of XNOR gate? 1, 0, 0, 1. Okay, this is the output for QB and QD XNOR gate. Okay, now when you are given clock pulse, first clock pulse, now what is QB XNOR QD? QB XNOR QD is 0, 0, so QA is 1. Similarly, when you have given next clock pulse, this 1 is shifted to QB. Okay, this QB is shifted to this one QC, and this QC value is shifted to QD. Okay, this is 1. Now, what is QB XNOR QD here? See this. This is the clock pulse 1 values we have. Since it is 0 and 0, output of XNOR gate for 0 and 0 is 1. So, QA is 1. Similarly, when you have given clock pulse 3, okay, when you have given clock pulse 3, okay, this QA is replaced with QB, QB is replaced with QC and QC is replaced with QD. Okay, when these are replaced, now what is the value of QA here? See here, QB XNOR QD. QB XNOR QD, that 1 and 0 value is 0. So this is replaced with 0. Okay, similarly when you have given 4th clock pulse, this 0 is replaced for QB and QB is replaced with QC. Similarly, QC is replaced with QD. Okay, now what is the value of QA? Look at this here. This is QB XNOR QD, that is 1 XNOR 0. So this is 0. QA value is 0 for 4th clock pulse. Similarly, when you have given 5th clock pulse here, okay, QA is shifted to QB, QB is shifted to QC, QC is shifted to QD. Now what is the value of QA here? QA is QB XNOR QD. Okay, now what is the value here? 0 and 1. For 0 and 1, the output value of XNOR is 0. Okay, for 5th clock pulse, QA value is 0. When you have given 6th clock pulse here, this QA is replaced with QB, that is 0. QB is replaced with QC, that is also 0. And QC is replaced with QD, which is 0. Now what is the output value of XNOR gate? That QB XNOR QD? 0 and 1. So this is 0. Again, the input is repeated. Okay, now after how many clock pulses we are getting repeated here? 6 clock pulses. Okay, or you can say clock cycles. Output is going to be repeated one. So option is B.